look at Chapter 8. So, Chapter 8 is going to be out here. This is going to be strings and regular expressions. Strings are real important, of course. So we have fruit, banana, that's a string, and you can pick one letter out, and the letter you'll get is A, the second letter, because it starts counting at 0. So fruit sub 0 is B, fruit sub 1 is A. All right. Here's fruit sub 0. All right. Now, all right. You can also use a variable, of course. This is going to be fruit sub 1. You can use expressions, of course, like fruit sub I plus 1 is the next letter, N. It has to be an integer. You can't try 1.5. Of course, that's going to be a problem. String indices must be integers, not float. That's a nice descriptive error message to help guide you. A nice friendly thing about Python. All right. And you can use the length to get the length of a string. That'll tell you how long it is. All right. And to get the last letter, you might try this, fruit sub n. Now that you know the length, but that's not going to work because if the length is n, the counting index goes from 0 to n minus 1. This is a very common problem with computing. We start counting at 0 instead of 1, which is pretty unnatural, and it leads to a lot of off by 1 errors and security problems, but that's the way Python works and most other computer languages too. So, fruit n minus 1 is the last one. Now you can also put fruit of minus 1, and that will be the last letter. Minus 2 is the second to last, and so on. And that's not very obvious why that would be, but that's the way it is. Now you can do string slices. You can go 0:3. That will go from the 0th character up to, but not including, the 3rd character. So you'll get the first 3 letters, B-A-N. All right. And so here, make binding. I'm not quite sure what to make of that. Oh, this is going to be how it draws a diagram, so I'm not going to really worry about it. It's going to draw some kind of diagram. There we are. Just showing fruit 0, 1, 2, each character. All right, fair enough. All right, so you can do :3. If you skip the first index, it starts at the start. So this would be the same as 0:3, first 3 letters. If you omit the second index, it starts at this character and goes to the end. So this will start at character 3 and go to the end. If the first index is greater than or equal to the second, you get an empty string. Starting at 3 and continuing but not including 3, that's empty. And they're saying you could even make this smaller, which I've never tried. I would assume this would be an error, but apparently not. That's interesting. All right. All right. And this one, I think you can probably guess, if you don't specify the beginning or the end, it's going to give you the whole thing. Now, strings are immutable, which is pretty annoying. So if you want to change one character, like change the first letter of it to J, you're not going to be able to because strings cannot be modified. And what you can do is you can recalculate a new string. This is what I often do, and I'm probably going to show you this, but this is what I do when I want to have this problem. I would set greeting equal to, get this here. There, I set greeting equal to J plus greeting. Do this kind of thing all the time. This is how you actually modify a string. You make a new string, building it out of the old string, changing that one character, and then you print greeting. That should do it. Yeah, that gives me Jello World. So that's you're creating a new object and assigning it to greeting. You're not modifying the existing object, which is immutable. It amounts to the same thing. It's just a little more clumsy. All right, and that's what they did here, the same kind of thing. All right. Then you can do string comparison, which is very handy. And I must say I appreciate it after using C, where you don't have string comparison. It doesn't work very well. So word is banana. If word equals banana, then it's banana. And it is. And so if you had even one character difference, like an S there, it's going to be false. All right. You can also do less than and greater than, and that's just going to sort them in alphabetical order. Now, apple comes before banana. That's true. Now, in ASCII, capital letters come before lowercase letters, so this would not be true, I think, if it's working the way I expect it to. Right. Apple does not come. All right. So anyway, that's upper and lowercase letters are treated differently, and uppercase letters are smaller. They start at 65. Lowercase letters start at 96, 97. So anyway, you look at your ASCII table, you'll see why. All right. all uppercase letters come before all lowercase. So, right, that's what I'm saying here. So comparing pineapple to banana. All right. So you can change everything to lowercase before doing a comparison if you don't want that strange relationship between upper and lowercase numbers, where the uppercase numbers are all smaller than lowercase numbers. All right. And then you've got upper to make the word uppercase, and you got lower to make it lowercase. And we read a file earlier, and here's how you write a file. First, you can check to make sure the file exists, and if not, you can download it. This is kind of cute. I must say I've done this a lot more sloppily in mine. I just have a line at the start that gets the file, and then after I've done it once, I comment out that line. This is a more professional way to do it. It'll download the file if it doesn't exist, and here it is downloading it. So now you can open it, and then you can read it. This will take a line and check to see if it's one of the special lines. We're looking for lines that start with 3 stars with information about the license. We can remove that. Okay, so we're going to see if the line starts with this. Okay, and we can now loop through the lines and print only the special lines that have the stars in it. And there you are. Okay, a couple of information about the license lines. All right, so now we're going to make a clean file that contains only the text without those lines. So we will set a reader is this, and a writer is going to be opening this for writing. Read is apparently default. I've always explicitly put it in, comma, put a read in here, but I guess if you don't, it defaults to it. So now we have reader and writer are 2 file handles, and so now we can loop through the file until we find the first special line. All right. This, by the way, is the policy we talked about in previous classes where you write your code a little bit at a time. So you just loop through it and make sure that works. And then when it exits, the line will have the special line, and it does. Okay. Now you can use a second loop to pick up where you left off. This will read the rest of the file. Well, that's interesting. I've never done this, where you have a loop and you break out of it, and then you resume picking up where it left off. I would have thought this would start from the beginning again, but apparently it knows where it left off. So that's cute. This will find the second special line, which is at the end. Okay. So when you're done reading and writing, you close files, these file handles, and now you can read the first. Now we created the file. Where did we create the file? Oh, writer. There. Okay, this is where you write the lines. Okay. So all the non-special stuff here. That created the file. Now, by the way, in this environment, you can see them right here. I should be able to see them, but I don't see them. Oh, there they are. Right, page 345 and page 345 cleaned. All right, good. Anyway, but you can also read it here and see what's in there. Dracula by Bram Stoker. Some of the lines are there. That's the first 2 lines. All right. And another very handy thing is find and replace. So we're going to count the lines in a cleaned version of the file. And now we're going to find lines that contain Jonathan. So if Jonathan is in the line, count how many lines have that. There are 199 lines. So it can't appear more than once in a line. So to get the total, we can use the count method. This will be how many times does it appear in that line. So it's actually 200. So there's one line where the word appears twice. And now you can replace Jonathan with Thomas with this way. For each line, replace Jonathan with Thomas. And that should do it. That should write to the replaced file. And the replaced file should only contain lines that contain Thomas, 201 Thomases, which seems a little strange. We only found 200 Jonathans. Oh, maybe there was another Thomas in there. Oh. Right. Anyway, all right. And if you, rather than simple replacements like that, you got regular expressions. You've probably come across them before, where you can have complicated patterns. Your pattern can just be a word like Dracula, which is fine, and then you can search for that pattern in a text, which will just repeat what we've done before. But you can also have more complicated patterns. They get hard to write and hard to understand, but you can do this, and it'll tell you where it matched the object. So you have result, and it has a variable string that includes the text that was searched, and a method called group that is the part it found. So those are somewhat helpful. And it has span that returns the index where it starts and ends. So you could pick the particular characters out that you want to put in there. If it doesn't appear, then it returns none, which I must say, PHP does this too. I highly disapprove of this. In my opinion, something that's returning a number should always return a number. It is pretty cruel to return a tuple of numbers and then return none otherwise. That makes it hard to deal with, but that's the way it is. So you can check to see if it was successful at finding out whether the result is none. All right, so here's a function that will loop through until it finds one that matches the pattern and return the match object. So it's going to go to every line, and if it finds the pattern in the line and it doesn't get an answer of none, then it'll return that result. So we'll get the first line that contains the pattern. So now we can find the first occurrence of the word marker in there, or harker, I guess. All right. Now these are technically regular expressions, but we haven't got any benefit out of the regular expressions yet. The regular expressions let you write these sort of mathematical summaries of what you're looking for. And here you go. The simplest one is the pipe that lets you look for Mina or Murray. That's a regular expression. So it'll find that pattern, be the first thing it finds, Mina. And you can also count how many times they happen. This is going to alert search the pattern and count how many times it happens. We'll see how many times Mina is mentioned. Well, I don't see why it's not also counting Murray. 229. I don't think this is counting how many times Mina is mentioned. I think this is counting Mina plus Murray. Let's just check that. If I had only Mina in there, right, I get 227. That's what I thought. So this is not the counted times Mina is mentioned. This is a mistake, I think, in your book. What they had there was Mina plus Murray. Anyway, all right, Mina or Murray. Anyway, this caret is useful. That means it has to start with this line. So we're going to find lines that begin where this has to be right at the start of the line, can't be anywhere in the middle. All right, and the dollars matches the other end. So you could look for lines ending with Harker and find those. All right. And you can do string substitution where you want to do cent-er or cent-re, where the English or the American spelling of this word. That's a pattern that will do it. So you'll find strings that have center there. All right. And you can check whether you use the British spelling of color, C-O-L-U. And this means the previous character is optional. So you might have the English C-O-L-O-R or C-O-L-O-U-R. Either one would be acceptable. And of course the British one used the British, this Dracula story is from Britain, so it uses the British spelling. All right, so if you want to convert it to English spelling, you could do string substitution where you substitute the pattern with the color. There, now you get colored stuff. All right. So you can search for lines and you can replace all the characters that way. And those are very simple regular expressions. You can do very complicated things with regular expressions, and they can get really baffling. Like I've seen the regular expression to describe a social security number, and it is mind-boggling. It's like half a line of text and symbols. So, these simple cases are pretty easy, but it gets very complicated. All right. And let's see. For debugging, you can use head for the start of a file and tail for the start of a file. When you put a bang here, that means it's a bash command, not a Python command. And this is what I usually do. Head shows you the first 10 lines of a file, and tail shows you the last 10 lines. Those are quite useful. And so you can even write them out. You can take the head of the file, then you can use greater than to put it out in another file, always starting with a bang, because these are bash commands, not Python commands. And you can also use a -100 here. Oh, to indicate 100. I always use -n space 100, but I guess you can use -100 too. That's interesting. All right. Anyway, so that's a summary of some text manipulation commands. And I'll stop this.